Hello everyone, in this video we're going to talk about algebraic expressions and formulas. But the first thing I want to do is kind of just review how do we do math. So I'm pretty sure we've all seen this or heard this before, right? Which are the order of operations, okay? And this just tells us how to add, subtract, multiply, and divide. In which order do we do this? Now, I know some of you may be sitting there thinking to yourself, please excuse my dear Aunt Sally, and I absolutely hate that. And here's why. I want you to take a minute and I want you to do this problem. So go ahead, pause the video, try to do this problem, and then when you get an answer, unpause it, because hopefully you got 4 as an answer and not 1. But I know a lot of people will end up getting 1, and that is the incorrect answer. So let me show you why it's incorrect. When we talk about the order of operations, we always want to do that parenthesis thing first. Now, I understand, this is the P, but really what it is, it's all about grouping symbols. All right, so you always want to do the work inside the grouping symbols. And what are grouping symbols? Parentheses, brackets, braces, even the absolute value. So anytime you see that, you want to do all the work inside the parentheses first. Next, you want to worry about exponents. All right, now that's pretty straightforward. Exponents are nothing more than just a number raised to an exponent. And what that means is you're going to multiply that number n times, or for example, something like 4 to the third power equals 4 times 4 times 4, which is 64, okay? Now, here's the part where students usually make a mistake, and this was the opening example. We do multiplication or division, all right? But here's how you do this. You do this in left to right in order. Meaning, if you read it from left to right, you do whichever one of these two operations comes first. You do not skip. You do it from left to right. Same thing with addition and subtraction. All right, you do them left to right in order as well. So, going back to the original problem, 12 divided by 6 times 2, we have to do 12 divided by 6 first, which is 2. And then 2 times 2 is 4. And that is how we do this. So I'm going to just go ahead and do a couple examples here, all right, where we just simplify. Let me get out a good marker here, make sure it's the same. There we go. I like that. So we're going to simplify 7 to the second minus 48 divided by 4 to the second times 5 plus 2. So just remember, and I like to write it on the right-hand side. I write it like this. We're just going to go left to right following these order of operations. So do I see any grouping symbols like parentheses? No. So I just put an X. Do I see any exponents? Absolutely. I see one here and one there. So 7 to the second is 49 minus 48 divided by 16 times 5 plus 2. I don't see any more exponents, so I can scratch that out. Next, left to right, I have to do this first. So 48 divided by 16 is going to be 3. So this is 49 minus 3 times 5 plus 2. Now I still see multiplication or division from left to right, so that's going to be right here. So this is going to be 49 minus 15 plus 2. And then finally going from left to right, 49 minus 15 is 34. And 34 plus 2 is 36. So this is how we use our order of operations. Now I'm going to do one more for us, and then we're going to move on into chapter 6, section 1. So we have the quantity of -8 raised to the second minus the quantity of 10 minus 13 raised to the second multiplied by -2. So once again, I'm just going to write these out real fast. Now, do I see parentheses? Yes, I see 2 of them. But let's be more specific now. With this first grouping, there are, other than the number -8, there's nothing else in there. So there's nothing else I can do in there, so I don't have to worry about that. In the middle grouping, I have 10 minus 13, which will simplify. So we're going to do that first. So I rewrite everything exactly how it looks. 10 minus 13 is -3. Now, you need to be very, very careful. I know many of us are probably looking here, and you're seeing that double negative, and you want to make that positive, but you don't. And the reason? Exponents come before multiplication or division. And this double negative, remember, you can think of that as -1 times -3. However, you can't do that yet because that -3 has an exponent of a 2. So you have to do that first. So let's go ahead. We'll go right down the list. Anything with an exponent, we're going to simplify. That is right here and right there. So the quantity -8 to the second power is positive 64 minus the quantity of -3 raised to the second is positive 9 times -2. So be very careful, okay? Now, we're done with parentheses. We are done with the exponents. Do I see multiplication or division? Yes, that's going to be right here. So 64. Now we have -9 times -2 is positive 18. And finally, 64 plus 18 is going to be 82. All right. So now that we've kind of warmed up here a little bit with the order of operations and just getting our minds thinking like mathematically, let's go ahead and let's start looking at algebraic expressions and formulas and stuff. So let's start off by defining an algebraic expression. So an algebraic expression, is a math statement that contains the following. All right, and I'm going to leave some space because I'm going to provide you with examples. So the first thing, we're going to call it variable terms. Second, constant terms. And the third thing is kind of like self-explanatory, but I'm going to write it out anyways. Math operations. Now, I'm going to start describing each one of these. So, for example, a variable term obviously contains a variable, all right, which is an unknown quantity. And here's what they look like. So variable terms can look like 3x or 1/2 y, or even something like -2x to the second, y to the third. I mean, it doesn't matter as long as it contains a variable. Now, this number that is in front of each one of these variables That has a very special name. That is called a coefficient. All right. So the coefficient is the number that is being multiplied to the variable itself. Constant terms are pretty much exactly what it sounds like. They are just strictly numbers. You can have 4, you can have -3/8, you can have the number pi, but they are strictly numbers. The math operations, well, there's only 4 of them that exist, and you already know the answer to that. Add, subtract, multiply, and divide. Now, some things that we can do with algebraic expressions are we can evaluate them. Now, to evaluate an algebraic expression, it's very simple. All you want to do is substitute a constant for the variable. Now, what I mean by that is this. Let's say I wanted to evaluate 3 plus the quantity, or I'm sorry, 3 plus 2 times the quantity x minus 3. And we want to evaluate this for x equals 4, x equals -3. Okay? So the easiest way to do this is to just rewrite the expression 3 plus 2 times the quantity x minus 3. And then what I'm going to do is directly underneath, wherever I see that variable, I'm going to put parentheses first. And then I'm going to evaluate this for x equals 4, which means I just substitute a 4 in. That's it. Now this becomes the order of operations. Do we see parentheses? Yes. So we'll do the work inside. 4 minus 3 is 1. Do we see exponents? No. Move on. Do we see multiplication or division? Yes. 3 plus 2. And finally, we can add to get 5. So as soon as you evaluate and you substitute in, it becomes the order of operations. So let's do this again, but we're going to do it for -3. So I'm just going to erase everything. Now we'll do this for -3. So do the work inside the parentheses. 3 plus 2 times. -3 minus 3 is -6. 2 times -6, -12. And 3 minus 12 is -9. Now, another thing that we can do with algebraic expressions is to simplify them. So simplify algebraic expressions. Now, to do this, we need some tools. And those tools are listed here. I'm going to pause the video, write them out, and then I'll unpause the video and you'll see them all and I'll provide examples. Okay, I am back in red. We're going to go ahead and do these. The first one is called the commutative property. Now notice you have a commutative property of addition and you have a commutative property of multiplication. The commutative property says order does not matter when you are adding. We don't care. For example, 3 plus 2 is the same exact thing as 2 plus 3 because 3 plus 2 is 5. And so is 2 plus 3. For multiplication, it's the same idea. If you're multiplying, the order in which you multiply does not matter. 3 times 2 is the same thing as 2 times 3 because they both equal 6. So that's our commutative property. The associative property says the order in which you perform the groupings, that doesn't matter as long as you are adding or multiplying. So that looks like this. Let's say we grouped A plus B first. Well, you can group them together, figure that out. Then you can add C. Well, that's the same exact thing as if you grouped B and C first and then you added A. For example, if I look at this on the left-hand side, I have the quantity 1 plus 2 plus 3. Well, 1 plus 2 is 3. 3 plus 3 is 6. Now, if you group it in a different manner, notice here we have 2 plus 3. We got to do that first, so that's going to be 5. But 1 plus 5 is also 6. The same applies for multiplication. You can group A and B and multiply them and then multiply C, or you could do it the other way. Now I'll use a little bit larger numbers here. So how about 2 times 3 times 4? Well, that's going to be 2 times 3 is 6. 6 times 4, 24. Now if I look on the other side, I can multiply 3 times 4 first. Well, that's going to be 12. And then 2 times 12 is also 24. So there's the associative property of addition and multiplication. Now, before we move on to the last one, you will notice here, you do not see subtraction or division. That's because there are no properties for subtraction nor division. They only apply for addition and multiplication. The last property is probably the most famous, and this is the distributive property. And what the distributive property says is that if you have a quantity B plus C and you are multiplying a number out front, what you are allowed to do is you can distribute by multiplying each term inside of those parentheses by the factor out front. So an example would be something like 2 times the quantity 3 3 plus 4. Now, if we just stuck with the left side, notice I would have to take 3 plus 4 first, which is 7. 2 times 7 is 14. Or I can distribute 2 times 3 plus 2 times 4. 2 times 3 is 6. 2 times 4 is 8. And 6 plus 8 is 14. So notice it still works out. Now, why do we need this? Well, when we go ahead and we simplify an algebraic expression like 5 times the quantity 3x minus 7 minus 6x, we kind of need a game plan for this, all right? Now, I know many of you could probably do this just by looking at it, and that's great. But if somebody asked you, hey, how do you do this? How would you explain it to them? And the first thing is you always want a game plan. So here are nothing more than just like our guidelines. All right. First thing, if there are grouping symbols, let me kind of write this neater. If we have grouping symbols, then distribute to remove them. Well, if you look at this, this is exactly what we just took a test on. This is logic. This is a conditional statement. If you meet the condition, grouping symbols, then distribute to remove them. So that's the first thing I'm going to do here. I see grouping symbols, so I'm going to distribute. I get 5 times 3x, 15x. 5 times negative 7 is negative 35 minus 6. Now, the second thing you're going to want to do, if you have like terms, then combine them. Once again, another conditional statement. If you meet the condition, like terms, then here's your conclusion. Combine them. But the big question here is, what are like terms? Like terms will always have two things in common. The first, you will always have the same variable or variables if there's multiple variables. And the second, you will always have the same exponent or exponents. So when we look at our example on the left-hand side, we have 15x, and that x is actually raised to the first power. And then you have a negative 6x, and that x is raised to the first power. So we're going to group them together first. To group them, just write them together. And then you subtract. So we're going to combine them to give us 15 minus 6 is 9x minus 35. And that is how you simplify an algebraic expression. So what I'd like to do is just do a couple more example problems. So directions are simplify. And we're going to simplify 7 times the quantity 4x to the second plus 3x plus 2 times the quantity 5x to the second plus x. And don't forget, here are our guidelines. I just copied and pasted them. So we're just going to go right through this. Do I see grouping symbols? Yes. Then distribute. So I get 28x to the second plus 21x plus, now let's distribute the 2, 10x to the second plus 2x. Second, do I have like terms? The answer is yes. I will color code them. So we have the x squared terms, and we have the x to the first terms. So that's going to be 28x to the second plus 10x plus 21x plus 2x. And finally, going left to right, group accordingly. 28 plus 10, that's going to be 38x to the second plus 21 plus 2, 23x. Now, the next example, we do got to be somewhat careful. And that's because of this. Let me go ahead and get our guidelines in here real fast. All right, that looks good to me. All right, now, the reason why we got to be careful is we have multiple grouping symbols, but you always start on the innermost. So that's going to be all of this stuff right here. We're going to do this first. Another thing we really got to be careful about is that minus sign in front of the quantity of x minus 2. Technically, there's a 1 right there. So do we see grouping symbols? Yes. Then we distribute to remove them. Start with the innermost. So 6x plus 4 bracket 7, and we're going to distribute that minus 1. So we get minus x plus 2. Now, within the grouping symbol, we're still going to simplify as much as we can. So we go down to step 2, which is, do you see like terms? And the answer is yes. In fact, here they are right here. You got a 7 and you got a 2. They're constant terms. So we get 6x plus 4 bracket negative x, and then 7 plus 2 is 9. Now, the process repeats. Do you have grouping symbols? Absolutely. So we're going to distribute that 4 to give me 6x minus 4x plus 36. Now that all the grouping symbols are removed, if we have like terms, then combine them, and we do. 6x minus 4x is 2x plus 36. So if there's one thing that I definitely want you to take away from this video, is that math is not some magical science. It is very strict and very rigid. There are rules that we follow. The question becomes, do you understand those guidelines? This is what the guidelines on the right side of your screen, that is what you study. That's what you know how to apply. I could come up with an infinite amount of examples on the left side of your screen. But as long as you know those 2 guidelines on the right, it doesn't matter what I give you, you can go ahead and simplify it. And that's going to be it for this video.